Hello, this is Mr. Miller and welcome to another statistics video. In this video we're going to discuss expected value, variance, and standard deviation. We're going to show how to compute these things from a probability model. If you recall, a random variable is a variable that can take certain values with specific probabilities. For instance, here we have a random variable x that can take the values 1, 2, and 3. The probability it takes the value 1 is 0.3. The probability it takes the value 2 is 0.5. And the probability it takes the value 3 is 0.2. Once we have a probability model like this, it might represent the winnings of a game. We can calculate how much we would expect to win on average. And we can also calculate measures of spread, the theoretical variance and standard deviation of our winnings. So the whole idea is before we ever play, we can compute a theoretical average and a theoretical standard deviation for our winnings. This applies to any other random variable as well. So first, I want to make a comment on the symbols and the formulas. Expected value we've seen, and people have been doing a really great job of computing it. A symbol for expected value is the Greek letter mu. It's like a U with two tails. I have a little trouble drawing it. And it's the Greek letter M for mean. Sometimes we denote the expected value with the symbol E, then brackets X. That means the expected value of X. And here's the formula. We have to add something up. That's what this sigma means. We add up what we get when we multiply the values of the random variable times their probabilities. Okay, that's how we compute expected value, theoretical average. Variance is another quantity. The symbol for that is a sigma. A sigma is a Greek symbol like this. It looks like a sideways 6. Sigma squared. That's the symbol for variance. Or sometimes we just call it VAR, var of x. And here's the formula. You have to take each value of the random variable and subtract the mean. You do that, you square it, and you multiply those values times the probabilities. A little bit more complicated for variance. We're going to do it by hand, but in general, you'd use a calculator or something like that to do it for you. Finally, once we have the variance, the standard deviation is just sigma. It's easy to calculate. You just take the square root of the variance. So you can think of variance being just a kind of a middle step on the way to standard deviation for what we're doing. All right, well, we really have one example here, and hopefully this one example will help you to do the problems in the assignment. We're going to create a probability model for the spinner game on the right. So this is kind of old news. The first thing I see is that we could lose $80. We could win $30, and we could win $90. Those are the values of our random variable, the amounts we could win. We need to write down their probabilities. Well, negative 80 takes up half of the spinner, so that probability is 1/2. The 30 and the 90 might be a little bit trickier. Each one of these is a sixth of the circle. You could see that if we kind of like extended these a little bit. We see that 3/6 of the circle is negative 80, that's a half. 2/6 is 30, which is equal to 1/3. And 1/6 is equal to 90. Okay, so those are the probabilities and the values involved. All right, calculate the expected value of x. I'm going to write E of x because I have a hard time writing mu. Here, I'll give it a try anyway though. Oh, that wasn't bad. That's mu. And we take the values times their probabilities. Negative 80 times 1/2 plus 30 times 1/3 plus 90 times 1/6. If you do that, you end up getting that mu, the expected value, is negative 15. On average, you're going to lose if you play this game. All right, calculate the variance. So that's sigma squared, which is the variance. Okay, we have to take each data value, or value of the random variable, negative 80, and subtract the mean. So I have to be careful here because the mean is negative. So it's going to be negative 80 minus a negative 15 all squared. So this is not going to be hard. It's just you have to be really careful with how you write these expressions and how you evaluate them. Plus, the next value of the random variable is 30 minus the mean minus a negative 15 squared times the probability, 1/3, plus 90 minus a negative 15 squared times 1/6. If you simplify the parentheses a little bit, let me see, we get, this would be negative 65 squared. I gotta make sure I put parentheses around it when I square it. Variance is always positive. Plus 45 squared times 1/3, plus that'd be 105 squared times 1/6. And if you do all that, you should get 4,625. Wow, that's the hard part. So you got to do the value of the random variable minus the mean, all of it squared times the probability. But the good news is when we get to the standard deviation, which is just sigma, we just have to take the square root of that. And we get 68.0. Okay. That's how you calculate the expected value, the variance, and the standard deviation. So we're going to practice it a couple times in the assignment. So one example, hopefully that's enough. Now you should be ready to do lesson 7.3 in the Google Classroom. Good luck.